This is Mr. Weideman, and I'm going to go over our warm-up problems. These are on page, I forgot, but number 28, 32, and 38. Oh, page 651. I'm sorry. Okay, so what are we going to do here? The common theme on all of these problems is going to be a common denominator. Your book does these problems. They use something called a conjugate. It works, but it's about twice the amount of effort. It's just simply getting a common denominator. And what do I mean by that? Here on the left, my very first thing that I'm going to do is I'm going to take cotangent and I'm going to change it into a ratio of cosine and sine. There is my cotangent. This other stuff, I'm going to leave it alone. And I left this big gap here because I want to multiply each term so I get a common denominator. And like I said, your booklet can solve this using something called a conjugate. So it's a lot of work. This is just so much easier. All right, so my common denominator is going to be sine times 1 plus cosine t. So that means this first term, I'm going to multiply it top and bottom by 1 plus cosine t. And then this second term, I'm going to multiply it top and bottom by sine t. And the tops, I'm going to multiply together. The bottoms, I'm going to leave in factored form. So let's look at this first term, and let's combine these. So I'm just going to distribute this cosine t, and I get that term. I'm going to leave the denominator in factored form. I suggest you do that in all of these problems, because sometimes if it's in factored form, you'll see something that divides out or simplifies. It's just not necessary to complicate things by distributing the denominator. All right, so then now that we have a common denominator, I'm putting in a lot of steps here so you'll see everything I'm doing. When I combine these two, let's take a look at the numerator here. And I have this cosine squared t plus sine squared t. And we know from our Pythagorean identities that equals 1. All right, so I'm going to get cosine t plus 1, and then in the denominator, 1 plus cosine t. This is the advantage of leaving it in factored form. Those divide out, so if I divide those out, it's basically 1 over sine t, which is indeed the cosecant. Okay, let's take a look at our next warm-up problem then, number 32. Same theme. I'm going to have two terms here on the left-hand side, and I'm going to give them a common denominator. In this case, my common denominator is going to be sine times cosine plus 1. So that means this first term, multiply top and bottom by sine. Second term, multiply top and bottom by cosine minus 1. I'm sorry, cosine plus 1, excuse me. Okay, now the first term is easy. Sine times sine, that's just sine squared. This other guy, we're going to have to FOIL it together. But it turns out that when I FOIL this thing together, it's the difference of squares. So the middle term drops out. And there we see that trig identity again. Sine squared plus cosine squared. That equals 1. So in the numerator, I got 1 minus 1, which is 0. So I can stop right there. 0 divided by anything is 0. So this expression we've identified, or we verified or proved that it does equal to 0. Okay, last warm-up problem. This one is a little tricky. But here is the strategy. Look at the top on the left-hand side. Tangent squared plus cotangent squared. The trick here is that is factorable. That's difference of squared. Tangent squared is perfect squared. Cotangent squared is perfect squared. So I can factor this just like I could factor x squared minus 49 to perfect squares, x plus 7, x minus 7. As long as I have two perfect squares, I can always do this. And then I noticed that after I factored it, this tan plus cotangent in the numerator and denominator cancel out, and therefore I've got it verified or proven that both sides of this expression equals tangent x minus cotangent x. Okay, stay posted, and we'll have more videos in moving on into Chapter 6.2. Thank you for your time.